All right, let's dive in. Ready to tackle the scientific method?
Always ready for a good deep dive.
This is going to help you totally crush Unit 2 on your exam. We're going to break it down so you can ace it, figure out how scientists use this thing to learn, how it's not just for labs, and we'll even see how creative and critical thinking fit in.
What's really cool about the scientific method is that it's how we think, like a structured way to investigate the world,
Right.
It's not just a rigid set of steps. It's more of a dynamic approach. Anyone can use it to problem solve.
I love that.
Yeah.
It's like a detective's toolkit for uncovering the truth.
Exactly.
So first up, observation.
Okay.
Our sources really emphasize that it's way more than just, passively seeing stuff. It's about actively noticing those little details.
Right.
And connecting them to what you already know. Like, remember that example? The student noticed that maize seedlings in the dark cover, they're sprouting these pale yellow leaves instead of the normal vibrant green. And that's when the scientific method kicks in, that curiosity, that's an odd moment.
That's when you really start digging in. A good observation, it often leads you to a question, a problem that needs solving. Like that classic story about Newton, For centuries, people just accepted that things fell down.
Right.
He didn't just accept it, though. He asked why.
Right.
That question, it led him to, revolutionize our understanding of gravity. It's the same with studying. Asking the right questions is key for deep learning.
Totally. So you've got your observation, you've defined your problem. Now what? It's time for hypothesis formulation.
Yes.
Coming up with those educated guesses. But it's not just like randomly throwing darts at a board.
No, definitely not. A solid hypothesis, it builds on what you already know and what you've seen. It's a tentative explanation that can be tested.
Right.
Sometimes the most unexpected things can spark a great hypothesis, though. Like, that story about Kekulé, the chemist? He was trying to crack the structure of the benzene molecule.
Okay.
Couldn't figure it out. And then, boom, he has this dream about a snake biting its own tail. That image, it made him think, what if benzene has a ring-like structure?
Wow, talk about a breakthrough. So we've got a hypothesis, but how do we know if it's actually true? That's where we get to experimentation.
Exactly. Experimentation is the heart of the scientific method. You design a controlled test, gather evidence that either backs up your hypothesis or shows it might be wrong.
Makes sense.
Let's go back to those maize seedlings. Let's say your hypothesis is that the lack of light is causing those pale leaves.
Okay, yeah.
How would you test that?
Well, I'd probably have two groups of maize seedlings.
Yeah.
One in the dark, like the first observation. The other group, I'd call it the control group, that would get plenty of light, keep everything else the same, the soil, water, temperature, so we isolate the light thing.
Right.
If the seedlings in the dark get those pale leaves while the ones in the light stay green, that backs up the hypothesis.
Exactly. That control group acts as a baseline. Now, after you've done your experiment, you got to look at the results and draw a conclusion.
Okay.
Did the experiment support your hypothesis?
And it's important to remember that science isn't always black and white. Sometimes those results, they might be inconclusive, they might make you rethink your original hypothesis, and you got to start over.
Exactly. Science is about constantly updating our understanding. But even when your experiment gives you a solid conclusion, there's one more important step. Theory formulation.
So now we're going from specific conclusions to a bigger picture, right?
I got it.
Yeah.
A scientific theory, it's a really well-supported explanation for a whole bunch of observations and experiment results. It's like this big framework that helps us understand a part of the natural world.
Like the theory of gravity, it explains why things fall down, but it also tells us why planets orbit stars and why we have tides.
Exactly.
Powerful stuff.
Remember, though, a theory is different from a hypothesis. A hypothesis is like a first guess, while a theory has a ton of evidence backing it up.
Okay, makes sense. So we've got the basic steps of the scientific method. But I'm thinking, how does this actually work in real life? Not just in textbooks,
That's a great question. It leads us perfectly into the next part. Let's say you wake up one morning with a strange rash on your arm.
Ooh, now that sounds like a mystery we can solve with the scientific method.
Absolutely. Let's break it down in part 2. So you wake up and there's this rash, right? What's the first thing you do?
Okay, well, I take a good look at it.
Okay.
See where it is, how big it is, the color. Does it have any texture? Is it itchy, painful? Any other weird things going on?
You got it. Those are all great observations. And based on those observations, what questions start popping up?
Well, like, when did this thing appear?
Right.
Have I used any new soaps or lotions, maybe switched laundry detergent, eaten anything out of the ordinary? been around any plants or animals that could have coined a reaction?
Exactly. All good questions. And those questions, they lead to hypotheses. Maybe it's the new laundry detergent, or maybe I brushed up against poison ivy when I was gardening.
See, now I'm a scientist. But to test these ideas, we got to do some experiments.
You got it. Experimentation. It's the way to go.
So for the laundry detergent hypothesis, I guess I could go back to my old detergent for a few days.
Yeah.
See if the rash clears up.
Exactly. If it does, that supports your hypothesis. But you always got to think, maybe it would have cleared up anyway, right?
Oh, yeah.
Doesn't necessarily mean it was the detergent.
Mm.
To really be sure, you might want to try that new detergent again, just on a tiny patch of skin, and see if the rash comes back.
Oh, like a mini experiment.
Exactly. That's how the scientific method helps us in everyday life. It's a powerful tool to understand cause and effect and make smart decisions.
It really is amazing how even a simple rash can be a scientific mystery. Speaking of mysteries, didn't our sources talk about a case in veterinary science that really shows how scientific discovery can have all these twists and turns? Something about a neurological disease in sheep, swayback.
Oh, yeah. The swayback case is a classic example of how using the scientific method can lead to some surprising breakthroughs. For years, scientists couldn't figure out what caused swayback.
What even is swayback?
Well, it's a disease where the sheep get this wobbly gait, like they're swaying, and they can eventually become paralyzed.
Oh, that's terrible. How'd they even start trying to figure it out?
Well, this vet in Western Australia, H.W. Bennett, he was determined to find the cause. Based on what he was seeing with the sheep and some research, he thought maybe it was lead poisoning.
So he had his hypothesis, lead poisoning. What did he do next?
Well, he decided to test it out using a treatment called ammonium chloride, which was known to help with lead poisoning.
So if the sheep got better, it would not only help them, but also support his hypothesis.
Exactly. And you know what? In that first trial, some of the sheep actually did show signs of getting better. Seemed like he was on the right track. But then things got a little complicated.
Oh, I love a good science plot twist. What happened?
In the next trials, those good results, they kind of faded away. The sheep didn't keep improving with that ammonium chloride treatment.
So back to square one.
Pretty much.
Sure.
Bennett had to rethink his hypothesis. But he didn't give up. He started asking new questions. Why did that initial trial show improvement, even if it was temporary? What else could be going on here?
It's good that he didn't just give up. I feel like persistence is so important in science.
It totally is. And his persistence paid off. He started to wonder if maybe the important thing wasn't the lead itself, but something else that was in that very first batch of ammonium chloride he used.
So like maybe there was a secret ingredient that was actually helping.
Exactly. It's like a clue in a detective story. So he very carefully analyzed that initial ammonium chloride batch and found out it had a little bit of copper in it as an impurity.
Ah, copper. So was copper the answer?
Well, he thought it could be. He tried giving pure copper to the sheep that were sick, and guess what? They got better.
Wow. Talk about a breakthrough.
It was amazing. And get this, before that, no one knew that a copper deficiency could cause disease in any animal. This just shows how the scientific method can lead to whole new understandings of the world.
It's a great story. Shows how observation, experimentation, and being willing to change your hypothesis can lead to incredible discoveries. But it also shows how important critical thinking is.
Totally agree. Bennett had to constantly think about what he was finding, question his ideas, and consider other explanations. That critical thinking, along with his creative problem solving, is what got him to the solution.
So it's not just about following the steps. It's about using those critical and creative thinking skills at every step.
Precisely. And this reminds me of another case. This one really shows how creative thinking can sometimes lead to totally unexpected solutions. We should talk about Ignaz Semmelweis, this Hungarian doctor who worked in a maternity ward back in the 1840s in Vienna. So we're talking about Ignaz Semmelweis. He's working in this maternity ward in Vienna back in the 1840s.
Okay, what's going on in Vienna?
Well, hospitals at the time had a pretty big problem, something called childbed fever.
Okay.
It was this awful infection, often fatal, and new mothers were especially vulnerable.
Oh, that's just heartbreaking. Sounds like a real medical mystery.
It was. Semmelweis was determined to find the cause, stop these deaths. He noticed something strange, though. The death rate from this fever, it was way higher in the ward where medical students delivered babies compared to the ward where midwives did it.
That is interesting. What do you think about that?
Back then, people didn't really know about germs.
Right.
They blamed stuff like bad air, Miasma, they called it.
Yeah.
Semmelweis, though, he wasn't buying it. He figured there had to be another explanation.
So he's already thinking outside the box.
Exactly. And here's where the creative thinking comes in. One of Semmelweis's colleagues, he accidentally cut himself during an autopsy and later died from something that looked a lot like child bed fever.
Oh, wow. A tragic but important observation.
It was. For Semmelweis, it was a light bulb moment. He thought maybe the medical students were carrying something from the cadavers in the autopsy room to the mothers in the maternity ward.
Wait, so he thought something you couldn't even see, some cadaverous particles, as he called them, were causing the fever.
Exactly. It was a radical idea, remember? No one really understood germs yet. But Semmelweis, he had this incredible leap of thought.
Wow, so what did he do with this radical idea?
He decided to test it, made a strict hand-washing rule. Medical students, they had to wash their hands with this chlorinated lime solution before they even went near patients.
So, like, he's inventing antiseptic practices before people even knew about germs.
Pretty much. And the results, they were amazing. Death rates from childbed fever, they went way down in that ward.
That's incredible. So his creative thinking, this wild hypothesis, it led to actually saving lives.
It did. Sadly, though, the other doctors, they didn't like his ideas. They pushed back, thought it was too simple, even offensive.
Reminds you that even brilliant discoveries, they don't always get accepted right away.
Absolutely. But Semmelweis's work, it paved the way for our understanding of germs and hygiene in medicine. It's a great example of creative and critical thinking working together, advancing knowledge, and making life better.
Totally. So listeners, whether you're studying for exams or just living life, remember, the scientific method, it's more than just steps. It's a way of thinking, a way of looking at the world with curiosity and skepticism, always seeking knowledge.
As you learn about the history and philosophy of science, pay attention to those moments, those sparks of creativity and critical thought that led to incredible discoveries.
Because in the end, the scientific method is not just about facts, it's about developing a mindset that can change how you see the world, how you tackle any problem.
So keep that scientific spirit alive. Keep asking questions, keep experimenting, keep pushing the boundaries of what you know.
That's a wrap for our deep dive into the scientific method. Best of luck on your exams, and never stop exploring.
Until next time, keep those brains buzzing.